Hello, I'm John Zilovakis, and I'm going to run you through a presentation on the decision support tool that we're developing under Work Package 5 of the Framework project that has the provisional title, the Farmland Ecosystem Assessment Support Tool, or FEAST for short. I'm just going to run through a narrative on agri-environmental management for biodiversity and ecosystem services with a specific landscape as an example to start. And then I'll do a demonstration of the prototype software that's under development that'll echo that narrative. So, thinking of our landscape, this is Ranscombe Farm down in Kent. It's just on the North Downs, very beautiful area just to the southeast of London. The red arrow on the map there at the bottom shows where the photo is taken from here. So when we're thinking about this landscape, what are we thinking is going on in here? Well, this landscape provides a range of different provisioning, regulating, cultural and supporting ecosystem services. And the Framework project is trying to bring together farmers, researchers and other stakeholders to share knowledge, test innovative practices for collective landscape scale biodiversity enhancement in agro-ecosystems, and hopefully provide improvements on how we value biodiversity and ecosystem services in our agri-food systems. So thinking about our farm at Ranscombe, what is it we might be expecting from this landscape? It's going to be very variable from farm to farm, from region to region. For example, we may want to produce food. We may want to maintain or improve the scenic or aesthetic and recreational value of the landscape. We may want to increase carbon sequestration to help with climate change. Or we may want to enhance or improve the populations of species such as birds, butterflies, plants, or many other species, reversing the declines of recent decades. We may want to do all of these, but it's how do we go about this in terms of tackling these various issues within our landscape? Well, maybe a starting point is to think about, well, what species are here? What's present in this landscape? We can draw upon various monitoring data to establish what is present in this landscape. This might come from a bespoke and systematic survey, or it might come from other sources such as the Global Biodiversity Information Facility, GBIF. When we look at that, we may find things like the brown big-eared bat was there in 2011. We find that the peacock was recorded in 2016 and 2018, and the collared dove was found in 2009 just in the foreground there. So it's starting to give us an idea of what's here, but it also may lead us to some questions such as maybe what's missing from this landscape? What should be there? Are there any personal or local priorities that maybe need to be addressed? And what needs changing to maintain or enhance these populations? Let's, for example, pick maybe butterflies and bats. What do we need to do in this landscape to actually improve it for their populations of these species? So when we're thinking about something such as butterflies and bats or any other species, once we focus on that, we're then going to think about, well, what is going on in this landscape that may be not as good as it should be, or maybe what is working well? Try to understand that. We need to understand what's going on in terms of agricultural activity that may be putting pressure on species. We need to understand, is there enough space? Have we lost a lot of habitat? Do we need to create new habitat? What is the quality of that habitat? How suitable is it for the species? Is it low or high quality? And thinking about this sort of configuration of the landscape, is it highly fragmented? Is it lacking connectivity? These are all things that can cause a range of issues for a number of species. So what can we do? Well, we have a lot of data. It's then a question of, well, how do we use that data that we have got to try and improve our understanding so we can manage this landscape better? We can use that data to try and make an assessment of habitat suitability, look at things like habitat complementation. Is there something missing, such as a food source or cover? We can look at assessing the agricultural pressure, what's going on in day-to-day management activities to understand what's causing any problems. We can look at the configuration of the landscape in terms of connectivity or zones of influence, or we can calculate the likely ecosystem services provided. These are all things that we can do to try and enhance our understanding and hopefully manage the landscape better. When we've got a better understanding of what's going on, then we can start to understand, okay, how do we go about improving? Once we diagnose the problem, what options have we then got to try and improve the situation? Now, I think it's fair to say we're not going to try and come up with a tool that says the answer is X to problem Y. It's all about presenting a range of options and the various pros and cons of each of those options. Often this is done with exploring what-if scenarios to see, would that work, would it not work? You can probably categorize them into sort of four main categories. Can we put in actions and options that will improve habitat suitability? Can we find ways of reducing the pressure from agricultural activities? Can we find ways of creating more space for wildlife species? Can we find ways of improving connectivity so that actually works better for these different species in these landscapes? Let's just use an example of that. It's a fairly simple example. Here we can see from the overlay here of the map, the woodland on the right here is quite isolated within the landscape. So when we do an assessment of its connectivity, we might find it's quite low. In which case we'll say, well, how could we improve that? Well, we could simply put in a new hedge, for instance, there, and then we might find the connectivity is improved, and then hopefully we end up with a better habitat for our butterflies and our bats. Of course, once we've actually put something in place, made some changes, taken some action, we then might want to know, well, has it worked? Have we got more butterflies and bats? We're almost sort of coming full circle to where I started with the monitoring data. Now we have a lot of data which we could maybe use to try and assess this situation. Have we actually made an improvement? What we tend to find is that we've got a whole range of different types of data, ranging from sort of direct observation and measurements through to sort of indirect measurements, surrogate indicators, modeled measurement, and so on, based on the data we can measure. And that tends to roughly correlate with the sort of outcomes that we're trying to measure versus the sort of activities and practices that lead to those outcomes. So ideally, we want to be measuring the species populations or measuring actual outcomes in terms of ecosystem services. But it's not always practical to do that, or it may take a long time sometimes before species respond to certain changes in the landscape. It's not instantaneous. And so we may then have to rely on other measures, on data we can collect, on that is readily available in the here and now. And we can use that to make calculations of ecosystem services. We can calculate again how the habitat suitability and connectivity is changing in the landscape, and we can measure whether agricultural pressure is going up or down. These can all be used to sort of monitor progress over time. So this leads me to the DST itself. How can the DST be used to help support decision-making processes in the management of this landscape? Now, some of the key functions might include things like calculations and assessments. This might be quite simple in terms of individual features, or it might be the whole landscape. It might be quite complicated in terms of connectivity and things like that. It can be arranged depending on what you need to know. We may want to have some sort of graphical visualization of data, be it simple charts or something more spatial in terms of zones being highlighted on a map. We may want to, in relation to that, sort of combine and overlay data, bringing data sets together to give us a better picture of what's going on in this landscape. And then, as we've just seen, what can we do in terms of identifying options and maybe then signposting users towards guidance and advice to help implement those options in terms of actions. These are all sort of things that the DST can do. At this point, I'm going to dive out into the prototype itself to give you a flavor of how this might be manifested within the software. So let's flip to that. So it is. I'm going to open the Ranscom file. First thing I'm going to look at is the monitoring data that we looked at in the slides. So I'm going to open here. Now this is data that's been collated in the GBIF, and it ranges all the way from 1800 to 2022. And I'm going to say, well, I just want to see where the bats are to start with. So we'll click on that, and then I'm going to put them on the map. So immediately we can see here we've got a number of them dotted around the map here. If I click on one of those, we can see those are the bat species that were monitored then back in 2011, and we can see our brown big-eared bat here. If we click on the link there, that opens up the GBIF record for that species, so you can access that information as well. So that's given us an idea, but we can see actually those weren't recorded anywhere near the location that we were looking at down here. So maybe we'll put on the birds as well to see what's there. So we'll have a look at the birds and then we'll add those to the map as well. So that's just chugged away. And now we can find, if we zoom in, we've actually got some birds that have been observed down here. And there's our collared dove that we saw earlier, located in the edge of the field there. So we can slowly but surely add this data in, and then that's then available to be used later on. We may then want to maybe just do a simple assessment, look at one of the blocks of woodland that we were just looking at, and then we can look at this particular woodland too, which was in our field that we were looking at. That's just here, so if I click on that there. This is all the input data that we've got about that woodland, so all its size and its features and all its qualitative parameters. I should say this is a very long list on here. That's because I've got all the indicators switched on for this prototype. So if you reduce the number of indicators, the amount of input data goes down. And then we've got a simple graphical representation here of the various calculations that are made. So for habitat suitability for birds, with green and red bars indicating positive and negative impacts. Likewise for ecosystem services. And then we've got more quantitative data on the QESA tab here, which is the various ecosystem services that are being quantified. We can also explore this information within the report builder, which gives us access to more functionality. So if I scroll down and look at our birds again here, we can see woodland 2 on the list here. When it's ranked against all the other features on the farm, is one of the lowest performing in terms of habitat suitability for birds. So that's given us an idea of its relative performance. We can of course do something a little bit more sophisticated. So if I go into the mapping interface, what we'll find displayed here is this is one of the QESA indicators currently set up. In this case it's pollination. So we can see all the different features on the farm and their various score for pollination, ranging from red from low to green to high. We can see woodland 2, which is this block of red down here, is not performing very well. And we can then, once we've got data in this environment, we can start bringing in the other data sets. So we might say, well, we're looking at pollination. Let's see where the bees are. How do they match up? Or we might want to put on our birds and our bats as well, so we can start seeing where that monitoring data is. Now, of course, this data has come from the GBIF. It hasn't been collected in a systematic way, so we have to acknowledge that. But if we did have systematically collected data, this could be added in as well. So we're starting to bring data together. Now, what we can also do is start to explore our sort of what-if options that I mentioned earlier. So if I switch on the connectivity assessment, we can see down here, that's our woodland 2. It's got a low score for connectivity. Now, this is a quite obvious example, but we can see as it's quite isolated, it's not very well connected. So then we can explore that example I saw earlier. What if we do put in a hedgerow along here to get it connected? So if I switch on the assessment where that has been done, we can now see that hedgerow has been put in place, and we can see all the colours have changed. So woodland 2 is gone from red up to a yellowy orange colour there, so it's improved in terms of its connectivity, and some of the surrounding landscape features would have also improved their connectivity score as well. Then we can start to say, okay, well, I'm interested in putting this hedge in place now then, if it's going to help. Then we might say, okay, what guidance is there available about hedges and wooded strips? And we might then bring up some example guidance. So in this case, it's an illustrated guide to hedgerow network restoration from Natural England. So again, we can start to sort of bring together information and data into one place to start help building a picture of what's going on and provide end users with potential options, which will hopefully lead to an improvement in biodiversity populations. That's all I'm going to show for now. Hopefully it's given you a flavour. I'll just whip back to the presentation just to conclude. So to wrap things up, thinking about this landscape and all the things we've shown you, what essentially we've been showing you is an environmental management system. And with environmental management systems, we've got this cycle of continuous improvement where we're taking information and data, combining it with the knowledge and expertise, implementing action, seeing what effects and impacts that has, and then that feeds around again. And we can overlay what we've been looking at on this cycle. So we've got our performance and diagnosis, we've got our options appraisal, working out, looking at our what if scenarios. We could potentially develop ideas to support action planning, be it directing and signposting to guidance or other outputs that can help that. And then we can make or help make assessments in terms of observation and indicators to see if what actions we're taking are actually delivering what we're setting out to do. Are we getting the outcomes that we want? Hopefully, with time, with this iterative process, what we should find that should lead us to a steady improvement in biodiversity and ecosystem services within our agri-food systems. That brings the presentation to an end. Just to say thank you for your time. We welcome any questions, ideas or suggestions. We are in a development phase of the tool, so now's the time to speak up and say, have what you've seen, does it look good or does it look terrible? Or have you ideas that you think would be nice to add to that? Any ideas, please put them forward. We are open to suggestions.